let's talk about synthesis reactions. So this is when two or more reactants combine to form one product. And the first type of synthesis reaction we need to talk about is when a metal reacts with a nonmetal to form what we call a salt. So here we have lithium, that's a metal, and nitrogen, N2, forming lithium nitride. So, remember, lithium has a +1 charge, nitride has a -3 charge. So this is how you'd write the formula for lithium nitride. This equation isn't balanced. It appears that we need a, let's see, if we put a 2 here, that balances the nitrogen, we would need to put a 6 here. So that is a balanced synthesis reaction. So you've got two elements, a metal and a nonmetal, and you combine them to form what we call an ionic compound or a salt. Okay, how did I know to write N2 and why did I not write Li2? Well, there are 7 diatomic molecules, and what we mean by diatomic, it means that you write them together, like N is always N2 when it is by itself in a reaction. So nitrogen is always found like this when it's by itself. It has a triple bond. Oxygen is another one. It's always found as a double bond like that. Then there is fluorine, chlorine, and bromine, and these halogens. Halogens will never double bond. But F2, Cl2 would be the same, Br2 and I2 with that single bond there, and then H2. So whenever you have any of these elements by themselves in a balanced equation, they must be diatomic. So the way to remember these 7, it's kind of cool. Nitrogen is atomic number 7 on the periodic table, and there are 7 diatomics, and it kind of, when you go across NOFClBri, kind of makes the number 7, although that's only 6 of the diatomics. And then there's hydrogen, who's always over here by itself. So 2 or more reactants combine to form one product. You've got to know those diatomics. All right, so let's try one more. Let's have nitrogen gas react with hydrogen gas to form ammonia. So this would be a synthesis reaction. So nitrogen is a diatomic, so you need to know those. And hydrogen, it's a diatomic, and it's going to form ammonia. And ammonia is NH3. So, is this balanced? It's not quite balanced. We need a 2 here and a 3 here. So that's one type of synthesis reaction. Again, this one isn't a metal and a nonmetal. It is 2 nonmetals coming together to form ammonia. A second synthesis reaction that you need to know is that a metallic oxide in water will make a metallic hydroxide. So let's see what that looks like. So we can put any metal with an oxide here. So let's go ahead and do potassium oxide. And when we put that into water, what we get, it's a synthesis reaction, and we get the metal hydroxide. So we get potassium hydroxide, and that would be aqueous. All right, so any metallic oxide in water will give you the metallic hydroxide. And to balance this one, we're going to need, let's see, we're going to need a 2 here, and that's it. So anyway, let's try another one. Let's do calcium oxide in water. Metallic oxide in water gives us the metallic, the same metal that's over here, hydroxide. Calcium is an alkaline earth metal, so it's +2, so we're going to need 2 of those. And now to balance this equation, it's already balanced. So this is something that you need to know. Metallic oxides in water will give you a metallic hydroxide. Okay, the last type of synthesis reaction I want to talk to you about tonight is when you have a non-metallic oxide in water, and that will form an acid. And in order to tell what acid it forms, you need to make sure that that non-metal keeps its charge or its oxidation number. So here we have sulfur trioxide, a non-metal oxide in water, and so non-metal oxides in water make acids. And so acids have these hydrogens out front, and then so we've got SO3 or SO4. We could make, maybe it's sulfurous or sulfuric acid, but we're going to go ahead and write H2SO4 and double check the oxidation number on the sulfur. Okay, oxygen is -2 and we have 4 of them, so that's -8. And the hydrogen is +1 and we have 2 of them. So this oxygen has a +6 oxidation state. Over here, oxygen's -2, we have 3 of them. So here the sulfur is a +6. So in this equation, sulfur had a +6 oxidation state here and a +6 here. So that is the acid that is formed from the sulfur trioxide when you put it in water. Sometimes you have to just kind of play around a little bit to get the right acid. You could have tried H2SO3. Let's see what happens when we have sulfur dioxide in water. And here you see the oxidation number on sulfur is +4, and so we're going to want the acid where the oxidation number on the sulfur is +4, and that would be with H2SO3, it would be sulfurous acid. All right, so metallic oxides in water form bases or metal hydroxides. Non-metallic oxides in water form acids. All right, that does it for synthesis reactions for now.